Imagine something that flows like a liquid, yet holds its shape like a solid, a strange state of matter that defies our basic understanding of physics. Welcome to the fascinating world of supersolids. And believe it or not, even light, something we usually think of as fast and untouchable, can be frozen too. Let's dive deep. First, let's start simple. You know solids, right? Like ice, wood, or metal, things that have a rigid structure. And you know liquids, like water, that flow and adapt to their containers. Now imagine something that is both at the same time. A supersolid is a new state of matter where atoms are arranged in a solid crystalline structure. Yet, the material can flow without any friction, just like a superfluid. The idea sounds crazy. A substance that can move without breaking apart, even while staying solid. The concept of supersolidity was first proposed in 1969 by physicists Alexander Andreev and Ilya Lifshitz. They suggested that in extremely cold conditions, close to absolute zero, a solid might exhibit superfluid properties. For decades it was just a theory. Scientists tried to find supersolids in solid helium, a material that behaves strangely when frozen. In 2004 some evidence emerged, but it remained controversial. Finally, in 2017, the dream came true. Two independent groups, one at MIT and another in Switzerland, managed to create supersolids using ultra-cold atomic gases like Bose-Einstein condensates. Making a supersolid isn't easy. It needs temperatures colder than outer space. We're talking mere billionths of a degree above absolute zero. Scientists use lasers and magnetic fields to trap atoms, cool them down, and manipulate them into a special quantum state called a Bose-Einstein condensate. In this state, thousands of atoms behave like a single giant quantum wave. Then, by carefully tuning the interactions between the atoms, sometimes using a laser field to create ripples, the atoms start to arrange themselves into a repeating structure, like a crystal, while still flowing like a liquid underneath. Supersolids aren't just cool party tricks for physicists. They could actually open doors to new technologies. Understanding supersolids could, lead to breakthroughs in quantum computing. We're talking about new ways to store and manipulate quantum information, which is honestly pretty exciting. Precision sensors. These are devices that can detect gravitational waves, tiny forces, or even magnetic fields with way more accuracy than before. It's kind of wild to think how much more precise our measurements could get. Fundamental physics is all about testing the limits of quantum mechanics and, who knows, maybe even uncovering new forces or particles in nature. Supersolids really challenge our understanding of matter, reminding us that even the simplest things, like solids and liquids, can behave in ways we never imagined. Now, what about freezing light? Isn't light supposed to be the fastest thing in the universe? Yes, in a vacuum, light always travels at about 300,000 kilometers per second, but in certain materials, light can slow down. In fact, scientists have figured out how to almost stop it completely. In 1999, scientists at Harvard University and the Roland Institute for Science managed to slow light to just 17 meters per second, slower than a bicycle, by passing it through a cloud of ultra-cold sodium atoms. Later, in 2001, scientists took it a step further. They completely stopped a pulse of light, storing it inside a cloud of atoms, then releasing it again, like pausing and playing a video. Okay, so here's how they did it in simple terms. First, they cooled a gas of atoms down to near absolute zero, which forms what's called a Bose-Einstein condensate. Next, they sent a pulse of light into that super cold gas. Then, using another laser, they created a special environment where the light's energy actually got transferred into the atoms. So, in a way, they were freezing the light's information inside those atoms. Later on, by switching the lasers back on, the light pulse was recreated and released. But just to be clear, it's not the photons themselves that are literally frozen. It's really the information they carry that gets stored, kind of like saving a file on a hard drive. Stopping light is honestly more than just a neat trick. It could totally transform the future of technology. Some of the most exciting applications include quantum memory. That means storing information carried by light for future quantum networks. Ultra-secure communication is, well, all about using light pulses as quantum keys for unbreakable encryption. Next-gen computing is helping to synchronize complex operations inside quantum computers. By controlling light like this, we can, actually dream of building networks that send information at the speed of thought, securely and precisely across the world and maybe even the universe. Supersolids and frozen light show us just how rich, weird, and beautiful the universe can be. At extreme conditions, matter and energy do things our everyday intuition really can't predict. Today they're mysteries we explore in labs, but tomorrow, they might power our technologies, our spaceships, and maybe even our dreams. Thank you for exploring the frontier of physics with me. If you enjoyed this deep dive into supersolids and frozen light, don't forget to like, subscribe, and hit the bell for more mind-bending science videos. See you next time. Check out our other videos like Quantum Entanglement Explained, or What is a Bose-Einstein Condensate, and hey, don't forget to subscribe for more awesome science content.